So that's the process. We'll do an example in a minute, but just before we do that, the general solution. For a 1 degree of freedom system, so this is back in chapter 2, the general solution looked like this, yes? Okay, this is free oscillation, undamped. We ended up with an equation that looked like this, a simple kind sinusoid. Cosine omega naught t times plus phi times by an amplitude of a certain value a. Now for a 2 degree of freedom system, okay, what happens with mass 1 will affect mass 2, and the same, and vice versa. And so x1 is going to be 2 sinusoids of certain amplitude c1 and c2, okay, and at that certain frequency, omega 1, which is the frequency of the first, and the omega 2, which is the second natural frequency. So that's x1. x2, you need to multiply that by the relative amplitudes. If c1 moves by 1 millimeter in terms of amplitude, then for x2 you've got c1, which is the 1 millimeter, times by your mode shape, r1. Okay, and the same thing for c2, okay, times by r2. And so you can put that in matrix form as well, okay, and basically you just replace x with x1 and x2, okay, so x1 is c1 times by 1 times by cosine plus c2 times by 1 times by cosine, and obviously x2 is c1 times by r1 times by the cosine plus c2 times by r2 times by the cosine, okay.